So that's just making a mark so that I know the depth that I need to go to. 0.375 inch stock, and I need to bring it down to 0.35. So I'm only going to take a 15th thou pass. And I'm going at 2,000ths per revolution, so let's see how this goes. And I'm watching the chip formation as well as my position on the DRO. So if anything goes wrong, I know where I am and everything about that. Measure where I'm at. Because it's a bit warm, that means that this material has expanded, and I want to measure it when it's room temperature. If it's expanded, and I go in and remove the amount of material I think I need to remove, when it contracts, it's going to be smaller than I want it to be.
No, we don't want that.
No, we don't. No, we don't.
Science rules.
Bill. No, So this is the drawing of the part I'm making. It's going to be a thread here. There's that 1/4-20 thread. Nominal length of 0.2319 inches. This overall diameter here, that can be seen right here. 0.35 inches is the nominal dimension, and this is my tolerance. It is plus or minus 10 thousandths. And look at that. Can you see the difference in that finish right there already?
Oh, yeah.
Yeah, that's what I like to see. The depth of the cut can impact that. The speed at which you're cutting can impact that. Where you're going fairly slow, so there's a very low chip load. The smaller your chip load is, generally the better your surface is going to be. We're also seeing a little bit less deflection in the material. And deflection is just the material bending. That's good. And feel that finish. That feels really nice.
Let's get a feel of this finish. Oh, yeah.
I'm going to chuck up on this a little bit more, and what I mean by that is push it further into the chuck just a bit. Now I'm just going to go ahead and check my clearances, make sure I'm not going to contact anything. When I'm cutting, it does not look like I will be, so that's good. Now I'm just going to come in here, find the ends, and actually my tool height's a bit high. You can see that the very edge is just above the center, and we don't want that, so I got to raise the depth. Okay, that's a bit better. So I'm just going to come in here and touch, make sure that I'm good. Call that my 0. I just found my face on this one, and I moved over so that my reference is from this edge.
We're gonna use this bucket to catch it. Nice catch.
Go. Yeah, there we go. It's cut off. Parting off, it puts a lot of heat into the part.
Yeah, I noticed it was a little deformed at the end there.
Yeah, so this right here, this is just a little nub that I'm going to machine down. When you're cutting, this has a lot of rotational inertia. The material just got too weak and let go.
Even metal gets too weak. That was really saying something.
That has me weak.